Hi everybody. Today I will show you how to detect flood affected areas using Sentinel-1 data in Google Earth Engine. In addition to detecting flood affected areas, I'm going to show you how to use GRC Global Surface Water product in order to reach the net affected areas by flood. Okay, let's go to do this. First of all, I have to detect the define and study area that flood occurred there. In order to do this, I'm gonna go to the northern part of Italy. I'm using draw a rectangle to do this. This area had been affected by a flood on the 2nd of May in 2023, and we are going to detect these affected areas by flood. Okay, let's go. In order to do this, I'm gonna visualize my study area in a better way. For this, I'm using center object and also map add layer. Okay, here I have to paste the name of my study area, that is geometry. The same thing for my map add layer in order to add my study area as a layer here. Again, the name of my study area. Okay. Until now it's okay, and I can save my script and run it. I'm gonna name it as a flood affected areas detection. Click on OK. And as you can see, it's saved by this name. Again, I'm running my code. Okay, until now it's okay. And we can go to the next step that is related to load Sentinel-1 data. For this, I'm gonna use, let's say, function. I'm saying that get Sentinel-1 collection. I'm gonna give it a start date and also end date that is related to start of the flood and also end of the flood. Okay, we need to define further details regarding the, let's say, collection that we are going to call. For this, I'm saying the return and use image collection. And right now I have to, let's say, put the ID of my Sentinel-1 SAR data here. In order to search for our data, I'm gonna come to the search and use Sentinel-1. Okay, as you can see here, it's here. We can see further details regarding the availability of this data, that it's available from 2014, and also a brief description regarding different parts of this sensor and also polarization and so on. And in bands we have different polarization. As I said before, we can choose. Here I need the ID of this image. For this one, I'm using this one. Okay, right now it's okay. I can go to the next step. Next step would be define my study area. For this, I'm gonna use filter band. In filter bands, I have to put the name of my study area, that is geometry. The next step would be the date that I need to define for detecting flood affected areas. Again, I'm gonna use filter date for this purpose. In filter date, I'm, let's say, giving my start date and also the end date. Copy and paste them here. Until now it's okay. I can go to the next step, and I need to, let's say, define my polarization. For this, I'm gonna use filter bracket, and inside the bracket I'm using again filter and list contains in order to call my polarization. I need to give you a brief explanation regarding the polarization that is using for flood affected areas detection. I have to back to my image, and from bands we have here different polarizations. I'm gonna use a VV polarization, that it means vertical. The reason for this usage is related to this. If you come, I will provide the link of this paper for your consideration. As you can see here, it mentions that because vertical polarization provides backscatters highly distinct in a wet areas, it's useful for detecting flood affected areas. Then, and also based on the previous studies, I'm gonna use this one in order to detect flood affected areas. Okay, let's go. Here I have to write transmitter receiver polarization. Okay, again, I have to define vertical polarization for my purpose here. In the next step, I'm gonna define my instrument that I'm going to use here. And again, I'm using filter. Filter again. This time I'm saying I'm using equal. The name of the instrument that I'm gonna use is IW. Instrument mode. Okay, IW. Okay, until now it's okay, and the reason for using this one, everything that is related to Earth's feature, for detecting or studying on these features, we are using IW. Okay, until now it's okay, and in the next step I have to select vertical, as I said before. I'm gonna put them inside, let's say. Okay, until now it's okay, and I can, let's say, close my code, and until now it's okay, and I can go to the next step. First I have to save and run my code. It's running without any problem. Okay, very good. Now I have to define pre-flood and also post-flood periods. In order to do this, I'm gonna use VAR. Also, I'm naming it as a pre-flood. And from my collection that I had here, I need its name. Okay. I'm gonna define my period from the, let's say, 20 until 13 of April, because as I said before, the flood occurred in the 2nd of May, and this time it's gonna be a good time. And from this I'm saying to use median of these datasets in order to convert them to individual image. I mean this image collection that I had before. And also for the last one, I'm saying to clip to my study area that it's gonna be geometry. Until now it's okay. I can go to the next line, and the same thing I have to do for post flood. Again, I'm gonna use VAR and post flood, I name it, from my collection. I have to define a specific period after flood. For this 1st of May would be okay until the end of May. Okay, the same thing for this one also, median. And for the last one, click to my study area. Again, I'm closing my line again and go to the next step. Until now it's okay, and I can run my code without any problem, and also I'm gonna save it again. Okay, until now it's okay, and we can go to the next step in order to compute the difference between pre-flood and post-flood. That is gonna give us affected areas by flood. To do this, I'm gonna use VAR again. I name it as a flood extent. Okay. Now I have to subtract post-flood from pre-flood in order to reach to the flood extent. In order to do this, I'm gonna say from post-flood dot subtract, okay, subtract pre-flood and get e.g. image 3 that I will explain about it to you about this number later. Clip. Okay, the name of my study area is geometry, and close the code here. Until now it's okay, and we computed the difference between pre-flood and also post-flood. That is gonna give us flood extent. Okay, until now it's okay, and we can go to the next step. Until now we computed flood extent that includes also water, existing water in our study area. However, I'm gonna reduce this existing water from the, let's say, whole the water that also includes flood, in order to reach a net amount of flood affected areas. In order to do this, I'm gonna use the GRC, global surface water product. For this we can also search here, that I'm gonna show you. Okay, for this I'm gonna use VAR again, and I'm saying GRC water. Depends on your usage, you can give it another name. And I'm using image collection in order to call our GRC product. I'm going to search, and again from here we can see different types of product that we have here. I'm gonna say surface water. Okay, we can see here our global surface water product. By clicking on that, we can see its availability from 1984 until, let's say, now. Here we can see a brief description regarding this product from this, also different bonds. And also we have another things related to this product. We have two types of GRC product. One of them is related to annual surface resources. The other one is related to the specific details regarding different water products. That I'm gonna use this one, because as you can see here, we have a seasonality, transition, occurrence, everything that you need you can find here. Okay, from here I'm gonna copy its ID, go back to my code and paste it here. Right now I'm gonna use select, because I'm going to select one of these resources. I'm gonna select seasonality, and the months that we have, let's say more than 10 months water exists inside the study area. This would be a good option in order to detect at almost permanent water resources in our study area. Okay, for this we can paste here, and until now it's okay. And now we can go to the next step, and let's say define a permanent water resources in order to prepare them for subtract from the flood extent. Okay, until now it's okay. We can go to the next step, and by using VAR, I'm gonna say permanent water. I name it. I'm gonna go to the further, and from my called global surface water product, I'm gonna say take water that are existing more than 10 months. and clip them to my study area. Very good. Okay, I can save my code and run it again. As you can see, it's run it without any problem. Right now, it's the main part of this one. I'm gonna, let's say, mask permanent water from the flood extent in order to reach to the net amount of flood water. Okay, in order to do this, I'm gonna use VAR again, flood affected areas. I'm gonna name it. And I'm using flood extent in order to update mask. I'm not using subtract, however, I'm using mask, update mask, and I'm using my GRC product in order to do this. And I'm saying that permanent water that are existing for more than 10 months is not included in my competition. Okay, this helps you to reduce the amount of the water that are existing during also flood occurrence in your study area. Okay, it's okay until now, and we almost down everything without any problem. Now I have to visualize different parts of my competition. For the first one, I'm gonna use flood affected areas. For this, I'm gonna say flood visualization, and again, I'm gonna give it a name, flood visualization. I'm gonna say minimum of flood affected areas would be 0 and max would be 1. I'm using palette. Palette, in order to give them again an appropriate color. For example, blue would be a good option here. You can choose whatever you are interested, but I'm using blue. Okay. Seems to be we have a problem here. I think this is the problem and solve it without any problem. Okay, until now it's okay, and we can go to and do the same thing for permanent water. I'm gonna give it a name as a GRC visualization. Again, the same thing. Min would be 0, max would be 12, because we have a, let's say, 12 months here in our GRC seasonality product that we selected here. Again, I'm gonna give it a color from palette, black. I give it a name, blue again. Okay, right now it's okay, and we can go to add all these competition to the layer. One of them is gonna be map a layer. It's gonna be permanent water that we computed before. And again, its visualization. In final legend, I'm saying to show it as a GRC, man and water. The next one, it's gonna be a layer. Now I'm gonna, let's say, add my flood affected areas as a layer. For this one, I'm gonna use flood affected areas. And again, palette to give it a specific color. Red. And the final name that I need to be added as a layer, it's gonna be final flood areas. Okay. Now I save and run the code again. As you can see, GRC permanent water and also final flood affected areas added as layers to my legend. Now I'm gonna show you the difference. Okay, if I go to my study area, and black areas are related to permanent water, and the red colors related to flood affected areas, that they are obvious in my study area. Very good detection of flood affected areas. As you can see, it separately detected flood affected areas from, let's say, existing water, and so this is cool. Okay, until now it's okay, and finally I can export my result into Google Drive in order to use in other software like ArcGIS or QGIS. For this purpose, I'm gonna use export image into my Google Drive. I need to specify some different feature for this result. I'm using image, and also the final things, it's gonna be flood affected areas. Okay, I'm using description to give it a name. Flooded areas, I name it. In the next step, I have to define my study area to be exported as the same as my study area. Geometry. In the next step, I have to define scale. Since the spatial resolution of my data is 10 meters, I'm gonna use 10 meter. And the final one is max pixels, 1E9. Okay, until now it's okay, and I can save my code and run it again. As you can see, it's added here. By clicking on run, I can easily download my data and open it in other softwares. Okay, a brief summary of this video I show you how to detect flood affected areas, and also use GRC in order to reach the net flood affected areas. That is very useful, and hope the content of this video will be useful for you. And if you like these types of video, please like the video and also subscribe to my channel.